Okay, Ji. Okay. So, if you do remember, so in the last video we have discussed the uh, demultiplexing, how it occurs at transport layer for UDP. Okay. So now we are going to discuss through example that how the demultiplexing occurs. How does demultiplexing occur at transport layer for connection oriented, that is for the TCP. Okay. So again I would like to explain that, for example, suppose this is a system. Its IP address is 1.1.1.1. Okay. And suppose on this system there is an application running P4, and this application P4 is associated with the socket, and this socket has source IP address 1.1.1 and source port number is 25 on this machine, and the destination port number is 2.2.2.2, and this is the IP address of this machine, and the destination port number is 5. So this port 5 is the port number of this socket and this of this application P5 on this system, and the connection is TCP. So the TCP socket is created here, and they have already established the connection. Okay. So a TCP socket, it is identified by 4 tuple. The UDP socket is identified by destination port number, and the TCP socket, it is identified by 4 tuple, by 4 things, 4 tuple: source IP address, source port number, destination IP address, and destination port number. Okay. So what does it mean? It means that when the transport layer, when the TCP at the transport layer, it receives the data. So when it receives the data, when the TCP at the transport layer receives the data and wants to move that data to the socket, to the application, want to pass on this data to the socket, to the application. So basically it uses these 4 tuples to identify that the data is for which socket, for which application. And the UDP, when the UDP receives the data at transport layer, so it wants to give the data to the application, to the socket, that it was using only the destination port number. It was using only one tuple, destination port number. But in the TCP, it uses the TCP at transport layer. It wants to pass on the data to the application socket. So it uses 4 tuples. 4 tuples: source IP address, source port number, destination IP address, and destination port number, to uniquely identify the socket or application to which the data is to be given. Okay. So what does it mean? Let me explain it through an example. So suppose again we received a packet PKT, this packet and this packet has the header information, source IP address is 2.2.2. So this means that the data is from this machine. The destination IP address is 1.1.1. It means that the packet is for this machine, and this packet is received on this machine. Okay. The protocol is TCP. The source port number is 5 and destination port number is 25. Suppose this packet is received on this machine, so it will be passed on from, it will be processed by physical layer, link layer, and network layer. So when it reaches to network layer, so which fields it use, which field it checks? The network layer, which field are checked by the network layer. Which field of the packet are checked? So we have already discussed it. That the network layer, it will examine source IP address, destination IP address, and protocol. Okay. It will examine the source IP address, the destination IP address, and protocol. So the source port number, destination port, source IP address, destination IP address, and protocol, that are its value, and their values in the packet are: source IP address is 2.2, destination IP address is 1.1, and TCP, the protocol is TCP. So the network layer will examine the destination IP address. Destination IP address is 1.1.1, and this 1.1, it matches to the machine IP address, because this machine IP address is 1.1.1. So the network layer will assume that this packet is for this machine. So therefore the network layer will accept this packet, and network layer will pass on this packet to transport layer. To which layer? To transport layer. Okay. So it means that the packet has arrived at this packet is arrived at the transport layer. So at the transport layer, which fields are examined? Which field of the packets are examined by transport layer? So we know it. So here the TCP, because the network layer, when it pass on the packet to transport layer, so at transport layer we have two options, UDP and TCP. So to whether the packet should be given to the TCP at the transport layer or to UDP at the transport layer. So the network layer decides it based on the protocol value. So the protocol value in the packet is TCP. So it means that network layer will pass on this packet to the TCP at transport layer. So the packet is received at the TCP in transport layer. Okay. So the TCP at transport layer, it will examine four things, four tuples. Source IP address, source port number, destination IP address, and destination port number. So what are the source IP address? The source IP address is 1.1. The source port number is 25. The source IP address is not 1.1. The source IP address is 2.2.2. This is wrong. Okay. Let me correct it. Okay. I think it will be then easy. This is wrong. This is actually 2.2.2.2, and this is 1.1.1. Okay. Okay. So as you know that the source IP address is 2.2.2, the source port number is 25, destination IP address is 1.1, and port is 5. So the TCP at transport layer, it uses these four tuples, these four values, to identify the socket, the application socket to which the packet should be delivered. So here this socket, it has these four values. So it means that this TCP transport layer, it will deliver the packet to this socket, and this socket is associated with the P4. Okay. So it means that and this is the socket with which it has established connection. It means that this socket cannot receive the data from another socket. Why? Because this socket has established connection with only this socket. So it means that it can only receive the data from this socket, not from any other socket. This is the difference. In the UDP, we have seen that in UDP, a socket can receive the data from multiple sockets. You can see that this socket can receive P1 socket, it can receive the data from P3 and P4 both. Why? Because if the in UDP and transport layer, it only checks the destination port number, nothing else. However, in the TCP at the transport layer, it examines the 4 things. So it means that this socket can receive the data from only one socket, not from many other sockets. Okay, so this is the one difference. So the demultiplexing, the receiver uses all 4 values to direct the segment to appropriate socket. Okay, so this is the difference of demultiplexing at the TCP from the demultiplexing at the UDP. Okay, so we have discussed it. Now there is a problem. What is the problem? A server host may support many simultaneous TCP sockets. How it supports? And each socket is identified by 4 tuples. Okay, so we can see that a web server, it normally have different socket for each connecting client, and we have discussed it in the program, in the TCP program server, if you do remember it. Okay, for example, here this is the TCP server program, and this TCP server program, this is the main server socket. This is main server. It is listening at this port, and when the connection is arrived at this, so from the client, so the connection is established and a new socket is created, server, and this server socket, it handles the client. For each client, a new server socket is created. Okay, so in the TCP, a socket can communicate with only one socket, not with many other. But in UDP, one socket can communicate with can receive the data from multiple sockets. Okay, so if in the TCP, in the web server, we can have non-persistent and persistent HTTP. So if we have non-persistent HTTP, then we will have different socket for each request. Okay, what is non-persistent HTTP? You already know. Non-persistent HTTP means that per connection only one HTTP object is received. Okay, so now what does it mean? Okay, so it is clear from this slide that the TCP at the transport layer, it wants to demultiplexing, that is, it wants to move to pass on the data to the socket, to the application. So it uses these 4 tuples: source IP address, source port number, destination IP address, destination port number, to identify the particular application socket. Okay, so this is clear. Now to discuss it further through an example. Okay, so you can see here that this is the TCP server. So for each client, for each application, it has separate socket. This socket is only receiving data from this socket, not from other socket. It cannot receive the data from other socket. It can receive only data from one socket. So one TCP socket can communicate with only one TCP socket. This socket is communicating with this application, this socket, and this socket is communicating with this socket. Okay, so this is the main difference, that in the TCP socket, it can communicate with only one socket. Okay, so this is the difference between TCP and UDP. Okay, so all these 3 segments, these socket, they use the same port number 80, but they have different socket IDs. So they have different applications. So the data is delivered to different application, and this socket is different from this socket. Why? Because a socket is identified by 4 tuples: source IP address, source port number. So here the source IP address is same. Source IP address of this machine, it is same for all 3 sockets. Source port number will be same for all 3 sockets, but the client IP address, the remote IP address, it will be different. The remote IP address for this application is this one, and the remote port number is different. So here for this socket, the remote IP address is the IP address of this machine, and the port number is different. So similarly here the port this port number will be different. Okay, so it means that because in these three sockets their IP address port number is same, the port number is 80 and the IP address of this machine, but the client IP address, the remote IP address, the destination IP address here for P4 is different. For P4 the destination IP address is P3. This is the IP address of this machine, and the port number will be of this machine, this socket. Similarly here for these two sockets, their source IP address and source port number is same. The source IP address and source port number is of this machine. The source port number is 80 for all three, including P5 and P6. And the destination IP address is also same, because the destination IP address will be the IP address of this C. But this port number and this port number will be different. So this is the differentiate between P5 socket and P6 socket. Okay. So how multiple sockets can be supported? So we have already discussed it in this previous lecture in the socket programming, that we can use threading. So by using the threading concept of operating system, by using the threading concept used in programming language, we can support multiple socket at a time. It means that the server can handle multiple socket, multiple clients at a time. Okay. So we have discussed the demultiplexing that is used in the TCP and UDP. So multiplexing and demultiplexing, it is explained through example, and I hope it will be clear to you. Okay. So now we are going to discuss another important concept, that is the UDP protocol. As we have discussed the HTTP protocol, we generally discuss the transport layer. Now we are going to discuss the UDP protocol. Okay. So now we are going to discuss the connectionless transport protocol UDP. Okay, we have already discussed transport layer services, multiplexing and demultiplexing. Now we are going to discuss connectionless UDP protocol. Okay. So I think it is clear to you that the UDP is a connectionless best effort service protocol. It sends the data as the data is arrived, and don't care about whether the packet is lost, packet is delivered out of order, packet is lost or not lost, packet is delivered or not delivered, packet is delivered in order or packet is delivered out order. But still it is used. Why it is used? Because some application, they don't require reliability. For example, streaming, they can tolerate the packet loss, so they use the UDP. Similarly, we have discussed the DNS application. If you do remember, domain name system. So domain name system is also using the UDP protocol. Similarly, we will discuss another protocol in the chapter number 6 or 7, that is simple network management. So SNMP is also using the UDP protocol. So this is their use. Okay. So UDP is a connectionless protocol. The packet can be lost. It is not reliable. The packet can be delivered out of order. And it is connectionless. Before connection establishment, there is no handshaking. The server and client, they don't establish connection. And therefore each segment is handled independently. So why UDP is used? So we have discussed that because there are certain applications in the internet that are used and practiced. For example, the streaming multimedia application, they can tolerate packet loss, so they use UDP. Similarly, the DNS and SNMP. Okay, but if you want the reliability in the UDP, so how you can do it? You can add reliability at application layer. You can add application specific error recovery mechanisms if you want. Okay, so that is up to you. Okay, so the UDP specification, its specification is available in the RFC 768. So what is RFC? We have already explained it. Okay, So RFC is a official document that specify the functionality of UDP and how they are used, syntax and semantic, each and everything. Okay. So now we are going to discuss the UDP header. So as we have discussed, if you do remember, so we have discussed that in the transport layer there should be some header information. We have discussed. We have discussed that transport layer must have source port number and destination port number, and the other fields that depends upon the protocol. Okay, so the source port number and destination port number, they will be available in the TCP and UDP, because and based on this port number it decides that the data is for which applications. Okay, so now we are going to discuss the UDP protocol header. Okay. So the UDP header, it consists of 4 fields, and source port number, the first field, it identifies the source application. Destination port number, it identifies the destination application. It is integer value, 16-bit integer value. Source port number and destination port number. Length, this field specifies the length in bytes of the UDP segment. What is the length of this segment? And it is specified in bytes. It is 16 bits. So it means that UDP packet can be 2 to the power 16 bits longer, maximum packet size. Okay. So, and the next is the checksum. We will explain what does checksum means later on. Okay. So these are the 4 fields. I think the source port number, destination port is okay, and the length is also clear. Why is there a UDP? Because it doesn't establish connection. So, okay, because if you want application that is delay sensitive, that means that it should deliver the data immediately, as soon as possible, without any delay. So we use UDP. Why? Because in the TCP there is delay to establish connection. After connection is established, then you can exchange the data. So the UDP removes this delay. The connection establishment delay is removed. So it means that it will be faster. It will be faster. It is simple. There is no connection state at sender and receiver. And the header size is small, just 4 fields. In the UDP, in the TCP, we will discuss that there are more fields. There are more fields. So header size is less. The overhead is less. This is overhead because this is not the data. Okay. There is no congestion control, so UDP can blast away as fast as desired. Okay. Okay. Now we are going to discuss why we use checksum. Why we use checksum. Okay. So basically, as we have discussed, if you do remember about bit error, how it happens. When we transmit the data, so the data is here stored. It is in 0 and 1 forms. When we send the data on the link, then the data is encoded, changed to signal, and the signal is transmitted on the link. And with this signal moves on, it propagates over the link. So for example, here the signal, this is the signal generated, and when this signal moves on the link, propagates through the link, so it, due to noise or due to interference, due to attenuation, due to distortion, due to noise, the signal can change. The received signal can become this way. What does it mean? That when you send 0 1, it may become 1 0. So the bits can flip. Okay, this is called bit error. This is called bit error. Okay, so if there is bit error happening, so how we can detect the bit error and how we can recover from the bit error. So for this purpose we used a mechanism that is called checksum. This is the a mechanism in bit error detection mechanism. We will discuss them in the chapter number 4. Okay, so bit error detection mechanisms, there are several bit error detection mechanism, but one of them is the checksum mechanism. So UDP use checksum mechanism for bit error detection. Okay, so how bit checksum works, let's discuss it. Okay, so the internet checksum, it is used to detect bit errors, the flipped bits in the transmitted packet. Okay, so it is used at transport layer only. So how it works? So for example, this is the data and we want to transmit it. So if you want to transmit it and you want to use checksum, so first of all, the sender side, we treat segment content into 16-bit integer. So we divide this data into 16 bits, 16 bit, 16 bit, 16 bit. So this is about 32 bits data, so we will divide it into two 16 bits. This is the first 16 bit and this is the second 16 bits. So the data is divided into 16 bits. Next, checksum, we perform additions. Now these 2 bit 16 bits segment, they are added. How they are added? So this is the binary addition, 0 0 0 1 1 1 and 1. So this is, and so on. So here there is a carry. When there is a carry, so the carry is again added to the data. Okay, so this is the sum. This is the sum of this data. Now after computing the sum, we take 1's complement of the sum. After addition of the 16-bit integers, then we took the 1's complement of the sum. So what is the 1's complement of this sum? So the 1's complement of this sum is this one. 0 will become 1, 0 will become 1 and so on. So this is the 1's complement. This is called checksum. This is the checksum code for this data. So after computing the checksum, how the checksum is computed? So first we treat the segment as 16-bit integer. So the data is divided into 16 bits. So because this is 32 bits data, so there is first 16 bit and this is the second 16 bit. They are added. If there is a carry, so we again add the carry to the sum. So this is the sum. So after addition, we have sum. Then we take the 1's complement of the sum. This is the 1's complement of this sum. So this 1's complement, then it becomes the checksum. So what we do? The sender puts the checksum value into UDP checksum value. So this checksum, it will be sent along this data. It will be sent along this data. This checksum, it will be sent along this data. And this checksum, it will be put in the UDP, this field. The checksum will be put in this field. It will be 16-bit integer value. It is put here. Okay, so it means that along with the data, we also send the checksum. Okay. So now, what we will do? We will send this data, and we will also send the checksum. And this checksum 16-bit value, it will be put in the UDP header checksum field. Okay. Now, when the receiver receives, so the receiver receives what? It receives the data and it also receives the checksum from the sender side. So this is the sender side checksum value. So what does receiver do? So receiver receives the data. It again compute the checksum of the received segment. So this data is received. This is the data. So its checksum will be recomputed. Again, this data will be divided into 16 bits. So these are divided. Its checksum is computed. This is its checksum. This is the sum, and again we take the 1's complement of the sum. So this is the checksum. Then the receiver computes the checksum of the received segment. After this, check if computed checksum equal to the checksum field value. Now the receiver will compare this checksum with the checksum that has arrived from the sender. Okay, so they will be compared. This checksum and this checksum, they will be compared. This is the checksum that is computed at the receiver, and this is the checksum that is received from the sender. So if both are same, it means that there is no bit error. There is no bit error. If they are not same, then it means that there is bit error. One or more than one fields are changed. One or more than one bits are changed. So if they are same, then no error detected. If they are not same, then there is the error. There is the error. If the both checksums are equal, then there is no error. If they are not equal, then there is error. Okay. So we have discussed the UDP checksum in detail. So I think it is clear to you. Okay. So by this the course ends. Okay. So the UDP header is also explained. Okay, so the UDP header is explained.